Hello, my name is Susan Symington, and I'm a computer scientist at the MITRE Corporation, and I'm absolutely delighted to be kicking off this session in trusted network layer onboarding and lifecycle management for IoT devices. We have two talks prepared for you today. I'll be talking first about introducing onboarding in the generic sense with no reference to any particular products or protocols. And our second speaker will be Elliot Lear of Cisco Systems, who will talk about some specific onboarding solutions and provide some details on those. So let's get started. With more than 40 billion devices estimated to be online in 2025, it's really not realistic for us to expect to be able to manage those devices manually. We need scalable mechanisms to securely manage those devices throughout their life cycles. And in this session, we're focused on the point of the life cycle when the device is being provisioned with its network credentials. That's a critical point in the life cycle because if that provisioning isn't performed securely, then the device is at risk of being onboarded to a network that's not authorized to take control of it. And the network is at risk of having unauthorized devices attached to it. So I guess we're all pretty much familiar with the onboarding problem. Just based on our experience with a typical home network, you bring home a device and you want to put the network password into it. But if it doesn't have an interface, it's pretty hard to do. And it's even harder to do that securely. And our home networks are insecure in the sense that all the devices share the same password. So if that password falls into the wrong hands, it's very easy for unauthorized devices to connect to the network. Ideally, we want to have unique credentials for each device. But with 40 billion devices, it's not going to be realistic to provision those credentials manually. And right now, there aren't really good options for zero-touch automated provisioning. So to address this challenge, we want a trusted mechanism for provisioning network credentials to IoT devices. And we'd like that mechanism to be open, standard, secure, scalable, and automated. And let's think big. Let's not just stop there, but let's have, as an added bonus, it would be great if that provisioning protocol could also support additional capabilities to secure the device throughout its life cycle. Now, what is trusted network layer onboarding? That's a great question, because if you look through the literature, there's not a clear consensus on the meaning. So here's how we define it. Network layer onboarding is the provisioning of network credentials to a device, and is performed when the device is deployed, not when it's manufactured. Trusted network layer onboarding is when the device is provisioned with credentials that are unique. The device and the network can authenticate each other before the provisioning. The provisioning occurs over an encrypted channel, so there's no danger of eavesdropping. No humans are given access to the credentials, and the credentialing can be performed repeatedly an unlimited number of times throughout the device lifecycle. So let's take a look at the steps that are involved in a typical network layer onboarding, a generic onboarding, okay? So what you're seeing on the screen here, on the left, you have an IoT device. On the right, you have a network. The device wants to connect to the network, but it doesn't know what its network password is yet. It doesn't have the credentials to do so. So we're showing a wireless network, but it could be also a wired network. It doesn't matter. Before the network onboarding begins, we assume that the device and the network are already provisioned with bootstrapping credentials. When the device comes out of the manufacturer, we expect it to have these credentials on it. And an example of bootstrapping credentials are a unique identifier for the device and a private key that the device can use to authenticate its identifier. Now, the first step in the network layer onboarding is some kind of introduction of bootstrapping credentials between the IoT device and the network so that they can trust each other to some extent. Now, an example of this would be somehow the network has to get the public key of the device and the device has to get the public key of the network. And this could be accomplished if they both have certificates. It could be accomplished in a zero-touch fashion in theory. But for some onboarding protocols, it might require a human to perform that introduction of the public key, for example. And we call that human a trusted onboarder. Not all onboarding protocols may need a human, and some may not. It's an option. So the next step is the device and the network authenticate each other, and they create a secure channel, and they use that channel for the network to send the onboarding credentials down to the device. And now that is a network layer onboarding in a nutshell, in its simplest form. But remember, before I said that we would like to be able to support additional security capabilities to protect the device throughout its life cycle. So we'd like to add another step before we do the provisioning, where we pass some information between the device and the network to accomplish that. I have 3 examples shown here. The first is an attestation token. The device could perform some sort of attestation, maybe measuring its hardware or firmware, send that up to the network, and the network could use that token as a basis for a decision to decide whether or not it trusts the device sufficiently to permit it to onboard. The second example is device intent information. This would be something like a MUD URL from RFC 8520. And the device would send device intent information to the network, so the network can be aware of what communications the device is permitted to perform, and it could use that to enforce those communications on the network. A third example is application layer bootstrapping information. The device could send application layer bootstrapping information to the network. Now, I haven't mentioned application layer onboarding yet, but you can think of application layer onboarding as analogous to network layer onboarding. It just happens at the application layer rather than the network layer. And just as the network layer onboarding requires that bootstrapping information exchange that I spoke about earlier, application layer onboarding requires a bootstrapping information exchange. So what better way to support that information exchange than to do it as part of the network layer onboarding protocol? So the next thing that happens is the device connects to the network using the credentials that were provisioned to it. Now, if device intent information had been sent up, then the network is already configured with access control filters to enforce the communications that were the rules that were sent to it. So in other words, the router is not going to let the device send or receive any information or any messages that it doesn't need to perform its required function. Now, if application layer bootstrapping information was sent up in the previous step, then right after the device connects to the network, it can automatically begin performing application layer onboarding. And by that, we mean the device and an application server would authenticate each other, establish a secure connection, and then the application server would download the latest version of the device's application to it. Also, as part of application layer onboarding, the device could establish a secure association with a lifecycle management service that could then manage the device for as long as it stays connected to the network. Now let's take a look at what points in the device lifecycle that onboarding is relevant. We've broken the lifecycle into 2 phases. In this slide, we talk about the supply chain phase, and the next slide, the use phase. In the supply chain phase, the manufacturer has a huge responsibility for supporting onboarding. The manufacturer has to make sure that the device is outfitted with the onboarding chipset. It has to install bootstrapping credentials on the device. And it has to establish itself as the owner of the device if the onboarding solution is going to support something that's called proof of ownership. Also interesting during this phase, the manufacturer may have to pass the device to one or more integrators to enable those integrators to perform an integration. And that means those integrators would have to onboard the device to their networks to perform the integration. So it's kind of interesting to me that the first time that the device gets onboarded may actually be during the manufacturing process. In the use phase, the first real owner of the device gets the device and performs application and network layer onboarding and application layer onboarding, as I described earlier. And the device reaches the operational phase. And hopefully it stays in that operational phase for most of its lifetime. However, periodically, the device may need to be disconnected from the network and re-onboarded. Maybe it needs new credentials, or maybe there's been a breach, so it has to have its credentials refreshed. And then later, when the device is no longer wanted on the network, or maybe it no longer works, it's disconnected and decommissioned. And if it's no longer wanted at all, it reaches end of life. But it's possible it could be repurposed on that same network, on a different network by the same owner, or it could be resold to a new owner and re-onboarded to a new network. So you can see onboarding may need to be repeated many times during the device lifecycle. Now, everything I've talked about so far is documented in a paper that we posted last year, and it's available online. And we're in the process of updating that in response to comments. And that paper was developed as a result of some document-based research we performed, but also a series of discussions that we held with a variety of onboarding stakeholders, device and chip manufacturers, network equipment manufacturers, users, service providers, and representatives from various consortia. And we benefited from their different perspectives and also their considerable expertise and experience. We tried to document everything we learned in this paper. The paper also provides a taxonomy of onboarding solutions, meaning it talks about different characteristics and capabilities that any given onboarding solution might support. And the most important of those characteristics and capabilities are related to security. Now, a lot of the security characteristics we identified are pretty standard, typical ones you would expect to be associated with the security mechanism, but others are noteworthy. For example, network selection is the ability of the onboarding solution to tell the device not only what its credentials are, but what network it should onboard to. Because it's possible that a device could have a choice of several different networks that it can onboard to, and we don't want it to be duped into onboarding to the wrong network. Also, the trusted onboarder, as I mentioned earlier, that's a feature that some solutions may require and others may not. And proof of ownership is a capability that if a onboarding solution supports proof of ownership, then it's possible for the device to cryptographically verify what entity is its owner, and it can use that information to determine whether a network is authorized to onboard it or not. We also looked at characteristics that weren't related to security, and we looked at these from three different viewpoints: the user, the manufacturer, and the service provider viewpoint. Within the user viewpoint, we broke that information down basically into two: the home user and versus the enterprise user. And we found some interesting distinctions. The home user is much more concerned with ease of use, whereas the enterprise user cares about things like bulk onboarding. Can you onboard lots of devices quickly with zero touch? And does the solution support device intent and proof of ownership, things like that? Manufacturers are very concerned with how complex the onboarding solution is for them to support, how much, what demands it places on the IoT device itself, how much secure storage is required and memory power, things like that, what bootstrapping information they have to install on the device, and also whether the onboarding solution supports things like device intent or proof of ownership that may require the manufacturer to have responsibilities that extend beyond just simply manufacturing the device. So now I'd like to tell you about an onboarding project that we recently kicked off at the NCCOE. The NCCOE's mission is to accelerate the adoption of secure technologies, and we collaborate with innovators to provide real-world standards-based solutions for business cybersecurity needs. We held a workshop back in November on onboarding, trusted network layer onboarding. And as a result of that workshop, the feedback we got there, we drafted a project description that it's available online. And in that project description, we describe our intention to demonstrate network layer onboarding and then hopefully other capabilities too. Now, where we are in that project right now is right near the beginning. Soon we'll be forming a team of collaborators who are committed to work with us to design, build, demonstrate, and document example onboarding solutions. Now, we don't know exactly what capabilities will be demonstrated because that will depend on who our collaborators are and what technologies they bring with them. But in the next slide, I just want to quickly give you an idea of the types of things that are potentially available. for us to demonstrate. As I said, we want to focus on network layer onboarding and demonstrate that we can do it in a trusted fashion and that we can do it repeatedly. We'd also like to demonstrate additional capabilities such as device attestation. If we could use devices that are capable of doing a secure boot and then taking measurements of their hardware, firmware, software, and sending that up to the network in an attestation token, then the network could evaluate that token to decide whether it wants to permit the device to onboard at all. We'd also like to integrate with trusted application layer onboarding, as I described before, and also support some security capabilities that would protect the device on an ongoing basis. For example, device intent, as I mentioned, and lifecycle management, mutual attestation. For example, if the device wants to access some sort of high-value data on the network could require the device to provide an attestation token that proves that the device is compliant before it allows it to access that data. And that could work in the other direction too. The device could require the lifecycle management service to perform attestation before the device is willing to trust that lifecycle management service to update the device. And we can imagine any other number of capabilities we could integrate with, for example, access management or device profiling or behavior analysis. So hopefully by now, you have an appreciation of the importance of trusted network layer onboarding, and you understand some of the different capabilities and characteristics that any given onboarding solution may offer. And if you want to learn more, you have the links to the two papers that we have. You can look at that more carefully. So in the near future, you should think about what onboarding solution characteristics are important to you and your use case, and perhaps draft some requirements, specifications, so that when those solutions become available, you'll be ready to adopt them. And when they are available, you definitely should adopt them as soon as you can. In summary, onboarding is a linchpin of IoT device and network security to protect the device, not only just during credential provisioning, but it can also play a crucial role in protecting devices throughout their life cycles. Now, before I wrap up, I want to thank the folks listed on this slide for providing some of the content in my presentation and also in Elliot's presentation. We're very grateful to them for their help. And I want to thank my colleagues at the NCCOE and at the MITRE Corporation. And most of all, I want to thank you, my audience, for your time and your attention. And next, I want to introduce Elliot Lear, Principal Engineer at Cisco Systems.
Thanks, Susan. That was really, really informative. My name is Elliot Lear, as Susan mentioned, and I work at Cisco Systems on IoT security, onboarding, and trust. And now I'm going to talk about 3 of the standards that have been developed over the last few years. In fact, they're just finishing up. So what you're seeing is a sneak peek, as it were, as the technology begins to diffuse. So the first technology that I want to mention is something called FIDO device onboard technology. It's so new that they only recently, they just approved it in the last few weeks. And this technology primarily covers onboarding, application onboarding, as opposed to network layer onboarding. And we'll just talk about it briefly to give you an example. The other technology that we're going to talk about is a cloud-based network application and application layer onboarding, something called bootstrapping remote key infrastructure. And since that's such a mouthful, everybody just calls it Brewski. But we're going to start off with the onboarding technology at the bottom, which is the Wi-Fi Alliance's Device Provisioning Protocol, or DPP, which is also known as Wi-Fi Easy Connect, and it's an optional component of Wi-Fi 6. And you can see, based on some of the information that Susan presented earlier, where these different technologies fit, right? You have the trusted onboarding, trusted application layer onboarding for 2 of them, trusted network onboarding for 2 of them, And I won't be talking very much about, for instance, device attestation, even though that's a very interesting area. So let's get started with DPP. We're going to get right into it with some diagrams. So the way that DPP works, or is envisioned to work initially, is that you have a cell phone, and that cell phone scans something like a QR code. That QR code contains a unique piece of information that only the device on the left would know, that printer that you're going to onboard. And the cell phone would communicate directly with that printer to prove to the printer that it has this one piece of information. And then once that's done, a configuration phase occurs. And during that configuration phase, the network credentials are passed from the cell phone to the printer. Now, this technology was originally designed for the consumer. It has recently been updated for enterprises, where rather than passing, say, a WPA3 or SAE passphrase, what can be passed during the configuration phase would be a certificate that could then be used with, say, EAP or EAP radius authentication. And once the configuration phase concludes, what then happens is the device just joins the network as it would, using whatever information was passed during that phase. So what's in that funky QR code? What is this secret sauce of DPP, as it were? This is what you would see in a QR code. And it contains some optional information like a MAC address, a serial number, but mostly what you see there is a public key. And the public key, what happens is that the device here, your phone, proves to the device on the left, the onboarding device, the thing, if you will, that it has the public key by encrypting some information in the public key, or essentially doing a Diffie-Hellman exchange, ECDH exchange. And then the device then proves back that it has the private key. Now, those of you who are paying very close attention will note that anybody who has that QR code can onboard this device. Now, one of the nice things about DPP is that it's pretty darn simple in this regard, in terms of that this is the only thing you need to onboard the device. As originally envisioned, though, you had to have this cell phone or something like that. But we can get in a lot more involved with DPP, and instead of, say, having the device directly talk to the cell phone, maybe it's talking to the routing infrastructure, which is off on the right. And you can look at that Wi-Fi router as maybe one router talking to, or maybe it's a bunch of routers in your enterprise that are controlled by that system above. And you could imagine the phone that's taking in that QR code talking to that system above and saying, providing that, and thus the exchange takes place through backend communications to the router to allow the printer to onboard. And so the nice thing about DPP is that it's rather minimalist, and you can build out additional capability on top of it, which makes it unique amongst onboarding technologies in that it is minimalist. The other ones are fairly complex, in my opinion. So let's in fact get to what the advantages and disadvantages are of DPP. So the first advantage, is that it is one-step provisioning as it's currently defined, and as people assumed there would be this thing that you scan the QR code. It can work with or without internet connectivity. And in the home, maybe you can assume that internet connectivity is there all the time, but if you happen to be in a military installation, maybe a little less so. So you need a little flexibility, and DPP provides that flexibility. Ownership transfers, such as there is ownership in the context of DPP, is merely a matter of resetting the device and then using that same code again. And I keep saying QR code, but all you saw there was a public key, right? Well, you can communicate that public key out of band through whatever other means too. It doesn't just have to go through a QR code. And the other advantage of DPP is that it doesn't require that a PKI be present through the manufacturing process. Now, people differ in terms of opinion as to whether that's a big deal, but if you think it is a big deal, and some manufacturers do, this is the one onboarding mechanism that doesn't require the PKI. On the other hand, there are some disadvantages, and those disadvantages include there are some chipset limitations. If you actually want to use the phone, those are being overcome based on new generations of chips. As currently envisioned, it was really a one-step onboarding process, not a zero-step onboarding process, and this is a bit of a trick for certain environments where they really don't have the people who can do the onboarding on site, for instance, so they have to do something a little different or enhance the DPP flow. There's no native anti-counterfeiting capabilities, and this is primarily developed for wireless technologies. Let's move to our next technology, which is Brewski. Now, Brewski is based on something called a voucher. And what happens is that the manufacturer is going to essentially generate this voucher and send it off to the device, basically with a signature saying, here's some information that you should know about this deployment. And that might include a trust anchor, for instance, that the device can use to trust the local deployment. But how does this information get from the manufacturer to the local deployment? And that's what Brewski is all about. So it starts with the device sending a voucher request into the local environment. And then that information gets forwarded to your registrar. This might be your AAA server. It goes up to the internet. And along the way, this guy here has noted that everything looks good. This guy here has received, as part of this exchange, a trust anchor that it puts in the voucher request and then signs. All that goes up to the manufacturer using the internet, and the voucher comes back and gets delivered into the device. And now, based on this trusted introduction, you can use other protocols like enrollment over secure transport to configure a normal device certificate for the local environment, and then use normal AAA functions like EAP-TLS for the device to onboard. So the benefit is that this can indeed be zero-step provisioning, at least in the first instance of onboarding. It has some basic anti-counterfeiting mechanisms that manufacturers can employ and customers can take advantage of to know that they're getting genuine equipment because it's all certificate-based. It leverages much of the existing enterprise infrastructure. If you have many of the commercial AAA servers already support EST, and Brewski is merely an extension to EST. Some disadvantages are that it requires an online manufacturer service, and it requires internet accessibility. And ownership transfer is required, which complicates matters in a long supply chain. And it requires a certificate infrastructure inside the manufacturer, and it does indeed need a little bit more work to support wireless in terms of scale. Now let's talk about FIDO's device onboarding technology. Now, this was based initially on a contribution from Intel, which was known as SDO, and now this is now FDO. And where it says review draft online, actually, that's now an approved FIDO standard. And one of the key goals of the FIDO specification is ownership transfer, and in such a way that you can have a late binding. And that late binding means many things. One of the things it means is that you can simplify device configuration for various locales or customers by having some amount of information arrive at the local deployment. And this might include firmware updates, it might include configuration updates. It's a very flexible architecture, but it is primarily focused on application onboarding. And so what you see in this slide is with and without. And what you end up having happen without FDO is for the manufacturer, it can mean having to have custom products, custom SKUs for different deployments. And we see this, for instance, in smart cities all the time, where you have very custom and bespoke per customer configurations. And the theory being, well, maybe there aren't so many customers, but as it turns out, there's a lot of cities. And this gets to be more complex as manufacturers grow. And so the technology is intended to simplify configurations with that late binding. So FDO can be zero-step. It has the same sort of anti-counterfeiting measures because it is also certificate-based, as say Brusky had, and it leverages much of an existing enterprise infrastructure, and that late binding is really something that is quite nice. From a disadvantage standpoint, it does require a manufactured reference rendezvous service. This is akin to the manufacturer service that Brusky offered, and that requires a little bit of an additional infrastructure investment somewhere along the way, either in the cloud or at a local deployment. Ownership transfer is required, but on the other hand, FDO has gone to great lengths to allow for supply chain management to not be quite so painful as, say, Brusky is today. And this is a major disadvantage in a network onboarding talk. FDO doesn't really support network and onboarding. It's primarily focused on application layer onboarding. So these are the three technologies that we've introduced. It's a sneak peek. They're all really new. Even DPP, which had its first instance a couple years ago, was just refreshed in December. Each of these have their strengths and weaknesses, and we will see other technologies. For instance, we know that there's more coming from the Connected Home IP Alliance, and there are lots of other technologies out there that will be developed because this is a very nascent area of exploration. But now is the time for you to explore. So here are some next steps that you might want to take. And the first is to have some notion as to how many devices are already connected on your network. These might be through 802.11 networks. They might be Bluetooth devices. It might be what we might call the sort of dark IT infrastructure that you might not be able to know. So you might even have difficulty counting these things. There's new technologies like Thread, for instance, that are coming down the road that use gateways. Do you have visibility? So one challenge that you should be taking on is making sure you're establishing that visibility. The second thing is to make sure you have a nice, strong infrastructure in place once a device is onboarded. After all, if you don't have that authentication infrastructure in place, what was the point of doing all this secure network onboarding? Finally, we recommend that now is a good time to talk to vendors about their plans. Because there are a lot of IoT vendors, you're going to want to have a lot of conversations. Right now, the standards, as you heard, are somewhat, let's apply the old joke. The nice thing about standards is that there are so many of them. It's a good time to talk to key vendors and ask what their plans are, and particularly talk about your needs as to whether you need zero-touch, one-touch technology, whether the internet can be there for you or not. And with that, I'd like to thank you very much, and I look forward to seeing you in person at a future RSA conference. And thanks to my co-speaker, Susan Symington.